Hello and welcome to this most wonderful time of the year. The Advent of Code is here. If you don't know what is Advent of Code, it's an advent calendar where each day new programming challenges open up for you to solve. So jump in and get some fun. If you're more interested in how it works, you can watch previous days, but today is day 3, so we continue. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They all are offline. Sorry about that, an elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I will try to get them online soon. You explain your need to get further down in the underground. Well, you could at least take the escalator down to the printing department. Not that you get much further than without the elevators working. That is, you could if the escalator weren't also offline. But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such occasions. The batteries are each labeled with their voltage rating, a value from 1 to 9. You make a note of their voltage ratings, which is your puzzle input. For example, this is the set of batteries. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each of these banks, you need to turn on exactly 2 batteries. The voltage that the bank produces is equal to the number of formed by the digit on batteries you have turned on. For example, if you have 1, 2, 3, 4, 5, you can turn on batteries 2 and 4, and the bank would produce 24 volts. You cannot rearrange the batteries. So it looks like we will have to toggle some batteries. You will need to find the largest possible voltage each bank can produce. In the above example, here it will be 98, 89, 78, and 92. The total output of voltage is the sum of maximum voltages from each bank. So in this example, the total will be this one. There are many batteries in front of you, so find the maximum voltage possible from each bank. What is the total output voltage? Okay, so we have a set of these batteries banks and we need to toggle 2 batteries in such a way that they make up the largest number in each line, and then we need to sum them together to get our password. And again, this is a great opportunity to try out different programming languages, so pick something you can learn or master your skills with. For me, it's Go because I'm getting old with it. So let's start by defining the part 1, which will accept the inputs and it will return the number back. So for now I will return it at 0. As in previous examples, I want to break down the problem in smaller steps, in more manageable steps, that I can quickly verify that it's working and use it as a building blocks for further development. So it's easier later to debug and find any issues if needed. So let's then define a function find largest voltage in this given input string, the one line, and it will return the number back. Let's for now return 0. And then actually maybe quickly can implement the part 1 because it's nothing more than we will define a password variable which will be the one value that we return back here. And here we want to iterate over all of these lines and sum with the largest voltage in this line. And actually that will be all the processing. It's now just up to us to implement how we can find the largest voltage. But before I proceed, I want to implement some test scenarios because I want to verify that it is working as expected and define some base cases to work from. So test largest voltage, and I will define it as some structure, so the input string and expected value to return back. Okay, and let's start with some simple cases, right? So if I would have 2 numbers, I would expect to receive the numbers back. So that would be the one of the scenarios. Then if I have 3 numbers, for example 1, 2, 3, then I expect to get the largest 2. So in this case it will be 23. Let's add something more like 9, 6, 5, 9. then the result should be 99. So first and the last one. And let's get something from the middle, for example. 19283. It should be 98. So these would be my first default scenarios that I will try on. Actually, we could do more. We could add the puzzle input, because we know that from this input, it should return 98. And from other inputs, so here it should produce 89. Then in the next one, it should be 78. And here should be 92. So these are the given examples that we can also use to verify our solution. And now let's run all tests, find the largest. If they are not equal, we throw an error. Cool, so we have defined test. Now, if I will run this test, of course, I will fail with all of those scenarios because we are just returning 0. So now for the implementation. So technically, it should not be that hard. So we have some input string of these numbers, and we are interested in finding the two largest number, and we are interested, it looks like we are interested in just finding two largest numbers. So for example, in this case would be 8 and 9, and we just need to find the correct order in which they appeared. So 8 and 9. Let's look if I would have some different example. 1, 2, 6, 4, 5. So in this case, it's also still the two largest numbers, which would make the end result. So it looks like we just need to find the two maximum values. So we need to go over each of the digits, right? So we can go through this input and get the digit out, which we can transform into the integer by subtracting the char value, right? And cast it to an integer. So let's find out which is the max value. Let's for now put it as -1. And actually we would need also to know the maximum position. So if our digit is larger than max, we can reassign and say that max is equal to this digit and this position is I. The maximum cannot be the last digit because we are currently looking for the first element. That's why let's put here that I is less than len input -1. And let's quickly add some debugging. So the maximum value here would be max at max position. Let's run our test. Okay, maybe too much tests to run at the same time. Let's start with one scenario. So the maximum value is 1 because we said we cannot be the last one. And maybe let's see here. I will run the third scenario, and the maximum is 9 at position 1, which is true. Okay, so we have found our first maximum value. Now we need to find the second largest number, which actually can only occur after our maximum value. So we can start from the next position till end. We get the next digit and we define here second max. And if the digit is larger than the second max, we say that it is as it is. So basically that should be enough for finding the second digit. And now that we have found both of them, we need to combine them together. We could like concatenate them together, or we know that it will be only two-digit numbers. So first we can multiply by 10 and add the second number. So max times 10 plus second max. Okay, let's run the tests. And everything passes, so we have implemented this maximum voltage. Let's now run this on our full part with all the calculations. Now we can run on this sample puzzle input. So input would be the strings, and let's copy over them from the puzzle here. So these are the inputs, and the expected value in this case would be 357. Okay, now let's compute the actual result. And if they don't match, let's throw an error. So let's run that, and it passes. So we have solved the sample input. Now each of you remember how your own input, which you can get here by the download link, and you will need to run it on full file, which is much larger, which I already have downloaded, and it's much larger input. So let's run on it and get the password for you to earn your first star. So let's then test part 1 on puzzle input. For that we will need to read the file. So let's ignore the error. It will be just for me input txt. Then we want to transform it into lines and split by the new line. So let's take the string bytes, and I'm on Windows, so I will also add the /r strings like this, OS. Yes, now the expected value probably will not know, but that because I have already finished it. But because I have already finished it, I can find it out. Then I run it on lines, and if it does not match, I will throw the error. Okay, moment of truth and success! We have earned our first star of the day. Now for the part 2. The escalator doesn't move. The elf explains that this probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning exactly 12 batteries within each bank. The joltage output for the bank is still the number of formed by digits of the batteries you turned on. The only difference is now that there will be 12 digits in each bank joltage output instead of 2. Consider again this input. We can see in first example, first 12 would produce the largest number. In this one, the first 11 and then last 9. And similarly here are more spread out. And we again need to find the total joltage. Okay, so this becomes much trickier because we need to find and turn on 12 such scenarios. So the gut feeling would say to do something like that we need to take the maximum and then we need to go on the second half and find the next maximum, which then again says to go to this part and take the next maximum, etc, that we continue until we get our 12 maximum values after each other. But here is one problem, that one of the maximum values could be at the end here. Start with this 6, after this 7, and I will try to find the maximum value. It will be 7 here. So the next maximum should be somewhere on the right side, but there is no more digits available. So it means that this is not the correct place where we need to search it. But this idea is close enough that we could use, but with a bit different, but with the attention to some minor details. You see that if we again take this same example and some sort of number of ones, we know that it will be always of length 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we could say that, for example, this is our base scenario. So now that we have arranged, and we could take this first pointer, and it can be any of these values. The first value will never be one of these right elements because it will mean that the length of the batteries will be less than 12. So it can be starting with this 12th element and further to the left side. So I can move pointer to one of these numbers. In this case, you see the largest one on the left side would be 9. So I put my first pointer here and remove it from here. And you probably can see that we can repeat this pattern. And now we know that the second one will be either this 4, because it cannot go to the right side, because it will mean that it's again less than 12 values. But it can be any maximum value between the last maximum found value and the current index. So in this case, it's again 8. And we could repeat that and move our pointers to the next largest value, just like that, until we find all the 12 largest numbers. So in this case, we can move it here to 1. And here it pretty much doesn't matter, but we could still try to find which would be the largest values. And by this we have found our longest 12 value sequence. So let's define here a function. Find largest joltage 12, let's call it like that, and provide the same input and the integer. And at the end, let's for now return 0. And define here a test scenario, or we could use pretty much maybe the same here example, except those the first one will not work here because there are no 12 digits. But here we know that it should be like that. Here it will be the same thing, only 9 at the end. Here it will be this number and this number. And here we change our tests. Okay, now running, of course, it will fail, and let's start implementing it. So I will create some sort of array. So here I will define those pointers, the digits, which will be an integer array, but with length of 12. And now I need to initially fill these pointers with the indexes of last 12 elements. So it means that if we have an array, the one will be here the length of the input, the last index. Then here we will have the length of the input -2, -3, and so on, where first element will become the input with -12. So let's take a for loop and go over the not input but digits, and we will put inside digits, and here we want to fill in with these indexes. So we will have the length of our digit, so length of our input -12 plus I. So we will set the last 12 indexes. But now we need to move this pointer and find the maximum value to the left side of it. And now we need to define the bracket in which we want to search for the values. So we will start from the right side, from the digit itself, and go to the left side. So the start would be digits itself, but the end would be here is a bit trickier, because in the first case it should go all over to the left side, but on the second iteration it should go to the digits. So for example, we could define that by default it's -1, that we want to go over the 0 index, and this will cover our first scenario. But we know if I is not 0, so we're not processing the first digit, then the end will be the previous found digit place. Okay, and now starting from start till the end, we subtract and we want to find now this maximum value. So first we need to find what is the digit again, and now we need to compare it to one that it's already stored. Remember those like 11 positions away. So here we need to extract the previous value. So previous value in this case would be from the input we take at the position of current digit that we look into, and transform it into an integer. And if the digit now is larger or equal from the previous one, then we have found our new winner, and we move the pointer to that position. And to keep things simple, just let's concatenate back all of these numbers and transform it into an integer. So let's go over these digits. So the position of the first number, let's define result as empty string, and let's add the digit that was at the input of that position. Then we need to convert it to an integer and return it back. Okay, looks good. Let's go for our test now. Let's run on these sample scenarios. And we have a failure. It is on 53rd line. And 53rd line is this one. We need to parse, we not need to take this index, but we need to take this one and parse that value to the previous digit. Okay, let's retest it. And success. So we have on our sample input got technically correct value, but that's not the whole part. Remember, we need to still sum it together. So let's define part 2 with the password, and that's all. And looks like that's all. And let's then maybe copy over the same sample input, but only now we will run part 2, part 2, part 2, part 2, and the expected value should be this one. Running that. Sample input is working. And now the large moment of truth again. So let's run on the real input, the part 2. Because I have already solved, I know the answer, I can compare it to it. So moment of truth. 1, 2, 3, and success! Just like that, we have solved day 3 and earned 2 additional stars. And again, I can repeat, the solutions could be different. It doesn't matter, is it fast or slow, it's just maybe some your interesting, clever solution. And if you had such, leave down that in the comment, I would be really interested in looking into it. Otherwise, I recommend you to try it the next day on your own, and later on come back tomorrow and compare the results with me. If you enjoy what you see, leave a like, subscribe so you don't miss the next one. But until then, keep coding, and I see you, well, tomorrow. Bye.